Good morning, class. So today we're going to continue our discussion of Chapter 3, which is the analysis of one quantitative variable. Right now in these early sections, we're dealing with descriptive statistics. So we have already looked at different types of graphical displays for one quantitative variable, which is a type of descriptive statistic. Today we're going to start talking about numeric summaries for one quantitative variable, which is another type of descriptive statistic. So today, our numeric summaries that we're dealing with are specifically measures of center. So one of the measures of center that we're going to discuss today is the median, which we've already looked at in previous sections. So remember that the median has the necessity of having the data in order. And so we have a data set shown to you here, which is already in numeric order, so it has to be from the smallest to the largest. And then the median cuts the data in half. So it's the center, just like the center of the road. So here, because our data is in order and because we have an odd number of observations, we can just simply locate our center, which is going to be 3. So there's 5 observations, so 3 is going to be the middle of that data set. The next measure of center that we have is going to be the mean. So the mean is the arithmetic average of a data set. We use X bar to represent sample mean, so it's the notation or the symbol used to represent the sample mean. Now, you've all probably calculated an average before, so the mean is a statistical way of describing average. So x sub 1 plus x sub 2, and you do it all the way out to x sub n. So this simply means that you do it for the first observation, the second observation, all the way to the last observation, where n is the total number of observations. So x sub 1 here would just be 0. X sub 2 is the second location in the data set, so it would be 2. So it just means the location. Now the mean, it does not have to have the data set be put into order. So I don't have to have the data in order, it can be. It's not like the median where the data has to be ordered. So summing all of those values, so we have a numerator of 14. So our mean then is going to be 2.8. So 14 divided by 5 gives us a mean of 2.8. So one thing that I want you to consider is situations where you have outliers present. So outliers significantly impact the mean, but don't impact the median as much. So it could also be skewness. So we say that the median is robust against outliers or skewness, and the mean is not. So the mean is significantly impacted by outliers or skewness and is not therefore robust, but the median is not impacted by outliers or skewness, so it is robust. So I'm going to show you what that means by adding in an outlier to the data set. So when you look here, I'm going to add in the observation 100. So we're going to use the pink so you can recognize the differences. So one thing also, when you have a median, if there's an even number of observations, you would take the middle location. So here, 3 and 4 are going to be actually where my middle is located. So to find this median, I'm going to take those 2 observations and essentially find the average for them. So if there's an even number of observations, you would take the 2 middle observations, add them together, and divide by 2. So I have a median of 3.5 here. So now, if I were to find the mean, I'm going to still add all of my observations, but I want to show you what happens when you do that and an outlier is present. So we have 0, 2, 3, 4, and 100. This time, because we added an observation, it's going to be divided by 6. So I have 114 divided by 6. So this time, I have a mean of 30.67. So you can see the significant impact that that outlier has on the mean. Here I have a mean of 30.6. It's very, very largely impacted by that outlier, whereas the median is not. I only moved a little bit with 3.5. So those are 2 looks at numeric summaries of center. And again, remember that when you describe a distribution, you have 2 measures of center now that you can use, both the median and the mean.